Hey everyone, welcome back. We are here at 6.2, lesson 6.2 in our geometry unit, and we have some vocab words here. So we are going to talk about some points of concurrency. So first of all, what does concurrent mean? Concurrent means that we have three or more lines that intersect. All right, so we have three or more lines intersect. So the point of concurrency is that point of intersection, okay? And sometimes we might refer to these individually as a type of center of a triangle. So we're going to learn about some different points of concurrency, some different so-called centers of a triangle. And the two that we're going to focus on today, or in this lesson, would be the circumcenter and then the incenter. So let's just talk about how these are created. So all of these are created by certain aspects of a triangle. And a circumcenter is created by the perpendicular bisectors where they intersect, where the incenter is created by the intersection of the angle bisectors. So we have a couple theorems that go along with all this. The first would be our circumcenter theorem. It says the circumcenter of a triangle is equidistant from the vertices of the triangle. So in this case, P is going to be our center here. So if this is our circumcenter created by the perpendicular bisectors, so I'm going to actually draw those in here. So they are created by some perpendicular bisectors, which means we have some congruent marks here because bisectors make some congruent statements. So basically the blue here is the beginning part, our if. So if PD, PE, and PF are perpendicular bisectors. So in these notes, this would be my blue marks. Then PA is equal to PB equal to PC. So that means we are going to have some congruent marks here. And this will be my red marks. So that is something that we are needing to know about a circumcenter. All right, now it just so happens, let's go ahead and draw a circle here. And then inside you can draw some type of triangle. Doesn't really matter what kind of triangle we have. And if we found the center of this triangle, we know from the edge to the center, that's called a radius, and these are congruent. When you can draw a circle around the triangle and all three vertices of that triangle are on the um, circle itself, that is showing the circumcenter. It just so happens from the circumcenter to the vertice of a triangle also represents the radius of that circle. Now let's go to the incenter theorem. The incenter of a triangle is now equidistant from the sides of the triangle. Now remember, it says that the incenter is made from the angle bisector. So let's go ahead and talk about what that looks like. So I'm going to have my blue marks be my angle bisectors, my if part. So we have some angle bisectors here. So those are angle bisectors. And then they all intersect at point P, and just so happens, and this will be my red marks, that where our angle bisectors meet, then that point is now equidistant. The sides, remember the sides are measured by a perpendicular. So those would all be congruent. Now, let's go back to that circle thing I did earlier. Let's go ahead and draw maybe a little bit smaller circle now. You go ahead and put the center, draw where you think that center is. Go ahead and draw now a triangle that's on the outside of this circle, and each side of this triangle touches the circle once. And what happens now is this triangle, if we did our perpendicular to each side, that will be my radius of that circle, and they are also equidistant. And just so happens, those are the parts that I have here in red with the diagram. So your incenter will correspond with the inscribed or inside drawn circle when it's compared with the triangle. All right, now that we have the theorems done and you just know a little bit about where some circles will lie inside or outside, let's get into actually practicing some of this stuff. So let's do number one here. So number one says that N is the incenter of triangle ABC, and use the following information. So if N's the incenter means that we have congruent marks, and we can do that for all of these questions, 1, 2, and 3. Well, let's just do question 1. All those distances from the center to the side of the triangle are now equidistant. Now, it just so happens ND and NE are also congruent. So because, and if I wanted to, I could write these in here. I could write the 2x minus 5. And, or by NE, I could write negative 2x plus 7. But because they are congruent, what I'm able to do is write 2x minus 5 equals negative 2x plus 7. And when I solve this, I'm going to get the x equals 3. Now, it does say to find NF. Now, NF, which I will highlight here in yellow, just so happens to be congruent to the other two segments. So let's just find the distance of one of the other two segments. So to do that, what we're going to do is take that 3 and plug it back in. So if I had 2 times 3 minus 5, I'm going to get that equals 1. So NF equals 1 for our answer. Let's go ahead and look at number 2 here. Again, NG, NH, and NJ are all congruent because N is equidistant to sides due to our incenter theorem. And just like before, they show us two of these parts. They show us x minus 1 is ng, and h is 2x minus 6. So all we're going to do is set these equal to each other. And when you solve, you'll get x equals 5. So if I plug that 5 back in here, 5 minus 1 is 4 for ng. And because nj is congruent to ng, that means if ng is 4, nj is also equal to 4. We would do the exact same thing for number 3, but I'm going to skip number 3 because we don't need to do 3 of these. All right, so let's look at number 4 and number 5 on the next page. So number 4, we have, it says find the indicated measure. Now here's what I see, is I see congruent marks on the segments, which means these, and I see these perpendiculars, which means these are all perpendicular bisectors. So first thing is we have a circumcenter. So make sure you look and discover or figure out what point of concurrency do we have here. Now, because we have a circumcenter, that means it is equidistant all the vertices. So I'm going to put in those congruent marks right there. Now, it just so happens, if I put those congruent marks in there, if PB is 13 and I want to find PA, which is right here, it just so happens they're going to be congruent with each other. So that means PA is also worth 13. Now let's go ahead and look at number 5 here. I see angle bisectors because I see all those congruent angles. So this is an incenter. Because it's an incenter, that means it is equidistant the sides. So if I want to find PS, which is right here, that is congruent to PU, which we know is 8. So this answer is that PS equals 8. Super, super, super easy to see on that one. And then let's go ahead and take a look at number 10. We're going to skip number 7. That's fairly easy also. Let's just look at number 6 though. Sorry if I said number 10. Number 6. Let's take a look at that. You'll notice that the center is outside the triangle. So there are some points of concurrency or centers of a triangle that are not inside of a triangle. But what I see here is I see some congruent marks in my segments. I see some perpendicular marks. So these are perpendicular bisectors. Therefore, we have a circumcenter. Now, because we have a circumcenter, if I find my vertices here, which would be E, D, and F, GE is drawn, GD is drawn, and we know those are going to be equidistant, so the congruent. I'm not going to draw GF, that's not even asked for. So if we want GE, which is right here, and we know based on our markings that is congruent to GD, which is 10, that means GE is also worth 10. For right now, because I know what we are testing and quizzing on, we are going to skip numbers 8, 9, and 10. So if you really want to, you can just give those a big fat cross off. And let's go to the assignment. So if you have any questions, please reach out. If not, we will see you here next time.